to understand the counting techniques, I'm going to start with a very simple example, which is there are 3 ways to go from New York to Chicago. Let me see if I can copy that. Okay. Okay. So there are 3 ways. I call them ABC. Those labels are messed up here. One second. All right, doesn't matter. I label these as ABC and these as 1, 2, 3, 4. So these first 3 are 3 ways to go from New York to Chicago. And then there are 4 ways to go from Chicago to San Francisco. So the question is, how many different ways are there to go from New York to San Francisco? So if I combine the first path A to 1, A1 is one way. But the first path A combined with the 2 is another. I mean, our question is distinct paths to go from New York to San Francisco. So A2 is another. A3 is another. And then B1, B2, B3. So altogether, how many are there? For each one here, we can combine all 4 in the second part. Each one here, 4 second part. So doesn't that mean 3 times 4 will be the total count? Everybody agree with that? For each one path here, there are 4 paths in the second part. So if you actually write down A1, A2, A3, A4, well, let me write it down. A1, A2, A3, A4, and then B1, B2, B3, B4, C1, C2, C3, C4 are the different paths. There are 12 of them. So basically it's same as the first number 3. 3 paths are there for the first part, 4 paths for the second part. 3 times 4 will give you the number. So let me ask you another question. Suppose that there's another city, Los Angeles. And to go to Los Angeles from San Francisco, there are 2 ways. So now the question is, how many paths are there to go from New York to Los Angeles through Chicago and San Francisco? What would be the answer?
24.
All right. So basically, this is 12. So you just have to multiply that by the 2. You're right. So 12 times 2 will be the answer. Basically, the number of paths. So if you have 4 different cities, basically you have to multiply the different ways of doing this part and different ways of doing the second part, different ways of doing third part, multiply them all. So we call this multiplication principle. So basically it's like this. There are 3 things going on. So you need to make 3 boxes. And then you say, okay, how many ways are there to do the first part? 3 ways. How many ways are there to do the second part? 4 ways. How many ways for the third part? 2 ways. Multiply them. That'll give you the number of ways of doing the whole thing, number of different ways of doing the whole path, the whole thing. That's 24 in this case. So that's called the multiplication principle. Notice that if I ask you a different question, you'll get the same answer. So this kind of calculation is going to come out in a variety of different problems, not just path. I used the path as an example, but let me clear this part of the screen and and ask you a question that's slightly different. The question is now, if I can use the letters A, B, C, I need to make a code word and make code word using letters A, B, C for the first character. You can have only 2 characters in the code word. The first character is going to be any one of A, B, C. The second part of the code has to be one of the numbers 1, 2, 1, 2, 3, 4. So how many different codes are there? You need to make one of these for the first to go in the front, and one of these will go in the back to get a 2-symbol code word. Then how many code words are there? Isn't that going to be same as these? Right? A1, A2, A3, A4, and B1, B2, B3, B4. So in other words, even for that question, the answer is the same. You asked the question, okay, so there are 2 parts here. The front has to be one of the letters, and how many different ways are there to do this part? 3 different ways. How many different ways are there to do the second part? 4 different ways. 3 times 4, 12 is the number of different codes. So very simple idea, and it works in all these problems. So let's go to this exercise. We did that exercise 1 already. Go to the exercise 2. John has 6 shirts, 5 neckties, and 3 pairs of pants. In how many different ways can he dress up? Can somebody answer that?
90.
I'm sorry?
90 ways.
Yeah, what did you do?
6 multiplied by 5 multiplied by 3.
Exactly. So same idea that we just learned applies, because to dress up, he's going to need a shirt. That's the one part. He's going to need a necktie. That's the second part. He's going to need a pair of pants. So in how many different ways can we do the first one? 6 ways, 5 ways, and 3 ways. So multiply them, that'll be your answer. All right, going on to box method. I just explained the box method. Basically, we call this, basically it's a multiplication principle, but if you put it in terms of these boxes, it helps to think a little bit better. So you first identify how many things are being put together. Like in this previous example, he's going to put together a shirt and a tie and a pants. So identify that and make 3 boxes. Then you ask the question, in how many ways can we do the first part? Then fill in that number. How many ways for the second? How many ways for the fourth? So if you think in terms of these boxes, it helps to figure out the numbers better. That's why we use this method called box method. All right, so let's do the exercise 3. It says how many 2-symbol code words can be formed if the first symbol is a letter and the second symbol is a digit. Now, let me remind you, a letter means an alphabet in English. There are 26 alphabets. How many digits are there? Anybody? How many digits do we use in our number system?
Infinity?
Say again? I can't hear you louder.
Infinity?
I'm still not hearing you.
Do you hear me better now?
One more time.
10 including 0.
Yes, 10 is correct. 1 second. Mark Anthony just entered. Okay, 10 is correct, because 1 through 9 would be 9 digits, and then 0 is also one of the digits. So there are 10 digits. Okay, so now the question is how many two symbol code words can be formed if the first symbol has to be a letter and the second symbol has to be digit. Anybody? What number times what number?
26 times 10.
26 times 10, 260 is correct. Very good. Let's go on to cleaning up the board. Now, some students came later. Now, this is something I warned at the beginning of the semester. If you come 5-10 minutes late, you cannot understand anything. That's how math is. And so, you were not here with for the first 10 minutes, and now you cannot understand anything. So I hope you will watch the video and learn from it before you do the assignment. Otherwise, you'll be completely lost.
Yes, Professor. I went to the wrong link, and then by the time I realized I was in the wrong one.
Wrong link. Okay.
Yeah.
All right. Sorry about that. That happens. So I hope you will watch the video and learn from that, because nothing is going to make sense now.
Yes.
All right. So let's go to the example 2. How many 5-digit numbers can be formed using the digits 0 through 5, 6, and 7? So we're going to make 5-digit number, and first digit cannot be 0. No repetition allowed. Second part says repetition allowed. So let's work with the no repetition. We're going to make 5-digit numbers. So see, it's kind of difficult unless you think in terms of the box method. So that's why I suggested using that. It's not just my idea. It is a recommended method for this kind of problem. We are going to go on to harder problems. So that's why organizing your thinking is necessary, and the box method helps. So can somebody tell me how many boxes to draw in this example?
5.
5 is right, because we are making 5-digit number. So I'm drawing 5 boxes, and then I'll ask the question of in how many ways can I fill the first box, and so on. So it says the first digit cannot be 0, and also no repetition allowed. So how many ways are there to fill the first one? Anybody? See, now the digits allowed are 0 through 7. Okay, not all of the digits. 0 through 7 are allowed. So what number should I write in the first box?
1 to 7.
1 to 7. So the count is what I need. The count of how many different ways are there to do this first box?
7.
7, right. Because 0 is not allowed. Altogether, there are 8 digits, as you can see. 0 through 7 would be 8 digits. 0 is not allowed in the first box. So therefore, 7 ways are there. After the first box, 0 is allowed, but repetition is not allowed. So can somebody tell me how many, what is the count to go into the second box?
7.
7 is right, because 0 is now allowed. So there are 8 symbols, but the symbol that is used in the first box cannot be used. So you only have 7 left. Everybody's with me? Even though there are 8 symbols to select from, the first symbol that is used here cannot be used. So therefore, 7 symbols are allowed. Next one, anybody?
Seven again.
Nope, not 7.
8.
Not 8. See, no repetition allowed. So there is one symbol used here. Now there are 8 symbols that can be used in all the boxes except the first. Only the first one you cannot use the 0. Elsewhere you can use 0.
It's 6.
But then you have to think about the repetition. Whatever symbol used here and here, there are 2 symbols already placed here and here. Those 2 cannot be used. So 8 minus 2, 6 allowed. Are you following me? If you understood that, you can tell me the next one. How many for
Five.
the next? Again,
5.
5 is right. For the next one,
4.
4. So it's not always straightforward. You had to draw the boxes and figure out how many different ways. So since no repetition allowed, as you go down, the numbers will go down. So if anybody is not following me, ask the question. I'm going to do the second part now. This is first part. In the second part, repetition is allowed. Let me draw the 5 boxes. You first we figure out what how many ways are there to fill the first box. Now same answer as previous problem, because there are 8 symbols, but this 0 is not allowed in the first one, so therefore there are 7 ways to do this. But when you go to the next one, 8 symbols are there because 0 is now allowed, and repetition is allowed now, right? So whatever symbol you used here can be reused here. So how many ways are there to fill this one?
8 ways.
8 ways. For the next one, anybody?
8.
8, 8, 8. Right. So when the repetition is allowed, that's what happens. Same number of things will go in the boxes. So now I'm leaving at this, but if it is your homework problem, you will have to multiply these numbers and produce one number. You enter that as your answer. One student just came in. So you have to actually do the multiplication and enter the answer in the box that they provide. Going on to exercise 4. Now this is exercise, so I want you to do it. In a city election, there are 4 candidates for mayor, 3 candidates for vice mayor, 6 candidates for treasurer. That's how many candidates are there. In how many ways can the office be filled? Okay, anybody has an answer? What to do? You just tell me what numbers to use.
Four, 3, and 6.
4 times
4 times 3 times 6.
3 times 6. Yes, that's right. Very good. That one is fairly straightforward. There are 3 office seats to fill. And for the first seat, there are 4 candidates. So 4 ways to fill the first one. For the second one, there are 3 candidates. And there are 6 candidates for the third one. Multiply them to get the answer. Let's go to the exercise 5. A combination lock has 20 numbers on the dial. The lock has 20 numbers on the dial. The opening code, the code that opens it, consists of 4 non-repeating numbers. So the code has 4 numbers and no repetition. So if you forgot the correct code, how many codes are there to try? Okay, first you tell me how many boxes to draw. How many boxes?
4 boxes.
4 boxes. The code consists of 4 numbers, so 4 boxes to fill. And now you have to figure out how many ways are there to fill. For the first box, how many different ways are there?
20.
20 is right. Very good. Second one,
19.
19. Third one,
18.
18. And
17.
17. Because no repetition. So whichever number used in the previous cannot be used. So therefore, the numbers will go down whenever repetition is not allowed. So the product of these will be your answer. All right, going on to exercise 6. One more time, another student came in late. So in any class, if you come in late, in any math class, it's hard to understand the rest. Fortunately, in this in these classes, everything is recorded. I'm going to put them on the board, blackboard, so you will be able to watch the video. So this rest of the class may not make sense for those students who came late. You're going to have to watch the video and learn from that before doing the assignment. We're doing exercise 6 now. Let me clear the board and let me read the problem for you. License plates in Maryland contain 3 letters followed by 3 digits. So first question is, how many different plates are possible? Anybody? Just tell me what numbers to multiply.
3 times 3.
Did you say 8 times 3?
No, 3 times 3.
3 times 3? No. The license plate is going to have 3 letters followed by 3 digits. So the plate will, okay, let me ask you the question differently. How many boxes are there to draw now? Don't
6.
try to just multiply the given numbers, okay? You have to think
6.
a little better.
6 boxes?
How many boxes?
6?
6 boxes is right. It says your plate, license plate will have 3 letters followed by 3 digits. So that means 6 things altogether. So therefore, 3 boxes for the letters, and then 3 boxes for the numbers. 3 more boxes for the numbers. So 6 boxes altogether in the plate number. So now you ask the question, okay, then how many ways are there to fill the first box? Anybody?
26.
Anybody has an answer for that?
26.
26, okay. There are 26 letters. Any one of those can go here. Now, the problem doesn't say anything about repetition. That's because you're supposed to figure that out from the context of the problem. Sometimes, sometimes they'll tell you, sometimes they'll let you figure out using the context. Now, think about license plates. Do we allow repetition on the license plates or not?
No.
We do. License plates do have repeated letters and numbers. So repetition is allowed. So how many ways are there for the second box?
3.
3,
Wait, no, sorry.
26.
26.
26. Where are you coming up with the 3? I want to try to explain to you.
I got confused by the 3 digits there for a second.
No. It says the question is, how many different ways are there to fill the box? So this first box, for example, can have any alphabet. So therefore, 26 different ways are there to fill this.
Oh, okay.
Okay, same way, second one. Repetition is allowed, so therefore, any of those 26 letters can go here. Same thing for the third one. 26 ways are there. For the red box, number is supposed to go there. So anybody, what's the
10?
10 is right. And for the next one,
10?
10 and 10, because repetition is allowed. And multiply them, that'll be your answer. And that number is a very large number. Let me
17 million. Around 17 million.
what's that again?
17 million.
17 million is right.
Around
So,
that.
17,576,000 is what I'm getting. So a second question says, if there are 330 people in Maryland, are there enough place to go around? What's the answer?
Yes.
Yes. With that system, they can make 17 million different plates, so that will be enough. Of all those plates, how many have all the digits distinct? All the digits distinct, part C. So you had to start over, draw the same 6 boxes. Now the letters can be still 26 times 26 times 26, but the numbers are distinct, means Still 10 goes here. What's the number for the second one?
9,
9 and
8.
8, because the same symbol cannot repeat. Then the part D says how many plates have distinct letters and distinct digits. That's fairly straightforward because now the box will have 26, 25, 24 because letters have to be different and the numbers have to be different also. So these are the numbers you have to multiply by. How many plates have adjacent letters or numbers not matching? Okay, that's a little bit tougher than those. Adjacent numbers and adjacent letters cannot match. Okay, so now the rule, you can still repeat, but you cannot have same thing side by side. That's what it means.
For the solution of C and D, would we just add all those numbers up to get the numbers?
No, multiply.
I'm sorry, would we multiply all those numbers to get the
Multiply all,
solution?
yes. Remember, this whole thing is about multiplication principle. And I explained why you need to multiply using simple example.
For C, we would do the same thing as well?
Yeah, see, you understood this path problem, right? There are 3 paths, A, B, C, and 4 paths, 1, 2, 3, 4 for the second part. Then A1, A2, A3, A4. Well, for each letter in the first part, each number in the second part can be combined. So that's why 3 times 4 is the answer, not 3 plus 4. Okay, you understand that, right? Samantha?
Yes.
Yes, okay. So it's all going to be multiplication, okay, not addition. And it's called multiplication principle. So we're at part E. How many plates have adjacent letters and adjacent numbers not matching? Okay, can somebody tell me how many ways are there to fill the first box now? The first box, you know, you're open to put anything in there, right? Any letter.
26.
So 26. Only for the second one, you had to think, okay, the adjacent letters cannot be matching. So that means how many ways are there to fill the second one?
13.
17?
No, 13.
13? You're going down to half. Why is that? See, repetition is allowed. So there are 26 letters available for the first one. Generally speaking, 26 letters available for the second one also, right? Because repetition is allowed. But because of the rule that says adjacent letters, adjacent means side by side, okay, next to each other. You cannot have matching letters or numbers next to each other, okay? With that rule, how many ways are there to fill the second box is my question.
25?
25 is right, very good. 25 because whatever the symbol you put in the first box cannot be used in the second because they're side by side, right? So 25. Okay, can somebody tell me what number to write on the third box?
24?
24 is wrong though.
26.
Say again?
26.
26 is wrong.
23.
No. $25. Let me explain why. You have 26 letters. You're placing one of them here. So let's say you place B here. Then you have only 25 letters to go here. Any one of the 25 letters can go here. Now, when you go to the third one, you are allowed to use the B there because that's not side by side. So you're allowed to use the B. You're not allowed to use the letter that you put in here in the second one. So only one letter you cannot use. You still have 25. Are you following me?
Yes.
Yes.
So you're saying that you're able to like do a pattern.
Yes. There are 26 letters allowed everywhere. Repetition is allowed. So 26 letters are allowed. only reason for having only 25 here is because the first letter that is used here is not allowed in the second. You cannot have same letter side by side. When you go to the third one, only letter you cannot use there is the letter that you use here in the second box. You can use the one that was used in the first one. So therefore, only 25. There are 25 to choose from. Everybody got that? Okay, then you tell me what's, the next box is number. So how many ways are there for the number?
10.
10. Any one of the 10 numbers, digits can go here. Okay, what's the number for the next one?
9.
9. And for the third one?
9.
9, right. Okay, anybody, if you have trouble understanding, except for those who came late, I don't expect them to be able to follow this. Others can ask me to explain again. All right, going on to exercise 7. So remember, each problem is different, but only thing common is that multiplication principle applies. So you can use the box method. Exercise 7, in how many ways can 3 people each have different birthdays? Assume that there are 365 days a year. So there are 365 days. So any one of those days can be a person's birthday. So in how many ways 3 people can have different birthdays? That's your question.
365 times 364 times 363.
Right, very good, excellent. The reason is we are talking about 3 people having different birthdays, so 3 boxes to fill. And so in how many different days, how many different ways are there for the first person to have a birthday? Any one of the 365 days can be the birthday, so 365. And they all have to have different birthdays. So for the second person, there are 364 ways to have a birthday, because he cannot have the same birthday the first person has. And 363 for the next one. So the product of those is the answer. Okay, so now we have finished with the multiplication principle, but now I don't mean that we can ignore it, forget about it. It's the beginning of counting techniques. The multiplication principle will apply everywhere. But we are ready to move on to factorial, another idea that we need to use. So factorial means a product of several numbers. Let me clear the screen. Factorial of a number is the product of all the numbers starting from that number down to 1. So that's why it's written that factorial n is right here. By the way, notation for the factorial is this. If I write 5 and then exclamation next to it, we read this as factorial 5. The exclamation is the symbol for factorial. So now the factorial means factorial 5 is just the product of 5 times 4 times 3 times 2 times 1. Starting from that number down to 1, multiply all of them. That's what your factorial is. So 60 to 120. So 120 is the actual value of factorial 5. Now let's find factorial 6. Factorial 6 is 6 times 5 times 4 times 3 times 2 times 1. And this part is same as factorial 5, which we already found as 120. So 6 times 120 equal to 720 is the answer to this. And if I want factorial 7, that'll be 7 times 6 times. Can you see that? It's 7 times 6 times factorial 5. Do you agree with that?
Yes.
Yes, because everything after that, after the 6, amounts to factorial 5. So factorial 5 we already computed. So 7 times 6 times 7 times 6 times 120. whatever that number is. I don't have to multiply. That will be your answer. But the point I'm making is this. Because of this, if I need to multiply, if I need to divide a factorial by another factorial like this, we can already see that factorial 7 is same as 7 times 6 times factorial 5, which is same as the denominator. So basically what you do is, starting from the 7, right, go downwards, 6, all the way down to match the denominator part, which is factorial 5. Then write the factorial 5 in the denominator. These two cancel out. Factorial 5 and factorial 5 cancel out. So 7 times 6 is your answer, 42. That's how you simplify a division of factorials. Students usually ask me this question. If I ask you to simplify factorial 7 over factorial 5, why can't I just multiply out 7 times, 5 times, 4 times, 3 times, 2 times, 1, and then divide by the product of 5 times, 4 times, 3 times, 2? Can you do that? Yes, you can. There's nothing wrong with that. But then why am I explaining this method here? There's a reason. This method of multiplying these out, multiplying the numerator out and then multiply denominator out and then divide using the calculator, will only work for certain numbers. It won't work for any numbers like this. If I ask you to find factorial 69 over factorial 66, something like that, if you try to find factorial 69 by multiplying out, that'll be 69 times 68 times 67 all the way down to 1. You won't be able to do it because your calculator will overflow and it'll not be able to find the answer. It's too big of a number. But if you apply this idea that I just explained, then you would write this top number 69, the 69 factorial as 69 times what? Anybody?
Times 68 times 67.
Times 67, and then write
66 factorial.
66 factorial. You go all the way down to the denominator number, write it out, and 66 factorial, you write it there. And then denominator is 66 factorial. These two cancel out. And so you only need to multiply these three numbers. Not only that, it's so much easier, but also possible now to do it. But if you try to calculate 69 factorial and 66 factorial, not only that, that's too much work, but also you won't be able to do it because the calculator will fail. So we must apply this technique to do those divisions of factorials. All right, so simplify these. The first question is example 4, factorial 6 over factorial 5. What is that equal to?
6.
6, exactly. If anybody is not following, ask the question.
I am not following. How
I'm
did we
sorry?
get 6?
Why is that 6?
Yes, how did we get 6?
Okay, let me clear the board and I'll write it down. The technique we just learned can be applied. So numerator is 6 factorial 6 and denominator is factorial 5. So therefore, this expression I'm going to rewrite with the numerator going down from 6 to, you keep going down until you hit this number. But, right after 6, everything that comes after this number in this factorial is same as factorial 5. So I can write the numerator as 6 times factorial 5. And now these two cancel out. Understand that?
Yes.
Okay. So the technique I just explained applies to all these problems. Factorial 8 over factorial 5. Can somebody tell me what that will be?
8 times 7 times 6.
8 times 7 times 6. That's right. Ask the question if anybody's not following.
Would we include the factorial of 5?
No, that gets canceled out. The numerator is equal to 8 times 7 times 6 times factorial 5. All that is equal to numerator.
So that would just be the answer, 8 times 7 times 6.
That will be the answer because the factorial 5 in the denominator will cancel with that.
Okay, and we wouldn't write the total as the answer, just as written as 8 times 7 times 6, right?
Yes, which you have to multiply. You multiply them, that'll be your answer.
Okay, so we would write the solution.
Yeah. So let me, 56 times 6. Oh. 336, you have to multiply 8 and 876, you get 336. That's your answer to this division. Okay. All right. Let's do part C. Says factorial 29 over 24. That's equal to the product of what numbers?
29 times
Times
28,
20.
20 times 27 times 26 times 25.
29 times 28 times 27 times. So where do I stop?
At
25.
25.
25. That product is the answer. Anybody having trouble seeing that? All right. Okay, going to part D. It says simplify factorial 12 over 12 minus 7 factorial times 7 factorial. All right, so it's a straightforward calculation. This 12 minus 7 is a normal subtraction, which gives you 5. So it's 5 factorial, 7 factorial. Now, to simplify this further, you have to use this technique that we just learned, which applies to a division of one number, 1 factorial by another. We have 2 factorials here. So what we have to do is we have to think of this as 2 divisions, 12 over 7 factorial, and then times 1 over 5 factorial. Now you can see that from your basic math knowledge, this product is same as this. That product is same as this because the denominators multiply together, numerators multiply together. So therefore you can imagine it this way. And then this part you simplify using the technique we just learned. So you don't even have to write this step. Okay, I just wrote that just to make sure you understand it. You can think of it this way. This combination of numerator and denominator simplifies to 12 times, 11 times, 10 times, 9 times. Where do I stop?
At
At 7.
7 factorial.
And the 7 factorial will cancel with the 7 factorial. So the
You
final
stop
answer,
at 6.
8.
8, right? The product goes up to 8. Everything that comes after that will cancel with the denominator. So therefore, this is the result of this fraction, this division, right?
Sorry, how did we include the factorial 5 when we were setting it up?
The problem has factorial. You're looking at problem 12 factorial 12 over 12 minus 7 factorial, and then another 7 factorial. That's what the original problem is.
Yeah, but in the problem, you put 5 factorials next to the 7 factorial.
Yeah, that 5 is 12 minus 7.
Okay.
The 12 minus 7 is simple subtraction. 12 minus 7 is a 5. So that's how I got the 5 factorial. Let me, okay, maybe I should start over for you. No big deal, I'll start over. Okay, so we have numerator has 12 factorial, denominator has 12 minus 7 factorial. and 7 factorial. Both are in the denominator. So I'm leaving the 12 factorial, and this part I'm simplifying. 12 minus 7 is 5 factorial. And I'm copying the 7 factorial as is. Now to go further, I'm combining the 12 factorial and the larger one in the denominator, 7 factorial, and simplify that part using the technique we just learned, which will give us 12 times 11 times 10 times 9 times 8. It will stop at 8. In other words, this division is equal to the product of 12, 11, all the way down to 8. We still have the 5 factorial left in the denominator. I have to expand that. 5 times, 4 times, 3 times, 2. I don't have to multiply the 1. That doesn't change anything. So you can always stop at 2. Now, this is my fraction. Can you now multiply 12, 11 all the way to 8 and then divide by 5, 4 all the way to 2? Yes, you can multiply them individually and divide by using the calculator. But I prefer the shorter way, which is to simplify common factors in the numerator and denominator. The 5 times 2 is the 10, cancels with the 10. 4 times 3 is a 12, it'll cancel with the 12. If you do that, it's a lot easier. 11 times 9 times 8. That's all I need to multiply. 72, 72, so that's 792. That's our answer for the entire expression. Everybody follow that, or anybody needs explanation again? Okay, if you understand that, I want you to do exercise 8. Can somebody tell me what numbers should multiply for part A, exercise 8, part A?
10 times 9 times 8.
That's it. Very good. That's the answer, the product of those. Of course, you have to multiply them and enter that as answer. Part B, anybody?
18 times 17 times 16.
All the way to
11 until 12.
12, yes. The product of those will be your answer. Okay, now I'm going to explain, let me clear the board and explain something. We need to understand how to go backwards. So this factorial, this part A, exercise 8 part A, we had a factorial 10 over 7. So let me start with that. Factorial 10 over 7 factorial was equal to 10 times 9 times 8. That's all that is, right? That product equal to this. Now, if I give you 10 times 9 times 8, this product, you had to be able to write this going backwards. So if I give you a product, you have to figure out what it is as a division of factorials. So if I give you 10 times 9 times 8, you can immediately see that the remaining numbers, I'm explaining one way of thinking about it, but usually most of you can immediately tell that this is going to be 10 factorial over 7 factorial, but I'm going to explain. So what I'm going to try to do is to make this number, make this product go all the way to become a factorial, I have to include 7, 6, 5, 4, 3, 2. And so if I divide by the same thing, then the number is not changed. If I multiply by those numbers and divide by the same numbers, the number is not changed. Now, if you look at the numerator, that's factorial 10, and the denominator is factorial 7. So that's why this is equal to this. So we have to go backwards. But without doing any work, most of the time you can immediately tell what it is. So let's do the exercise example 9. Can anybody tell me what is that as a division of factorials?
Eighteen factorial divided by 14 factorial.
That's right. 18 factorial divided by 14 factorial is right. So example 5, that's because, it begins at 18 and goes down 17, 15. So everything that comes after 15 will be equal to 14 factorial. So therefore, dividing 18 factorial by 14 factorial will give you that product. Okay. Exercise 9. Very similar, but the numbers are multiplied in the reverse order, but you can still understand what that means. So what factorial?
55 factorial divided by 50 factorial.
Divide by 50 factorial. Very good. Now, if anybody is having trouble understanding that, please ask the question. Okay, very good. All right, so now we are ready to go on to permutations. Permutations means a permutation is an ordered arrangement of given objects. A permutation means an arrangement of whatever the objects given. Then we are going to be calculating the count of permutations. How many permutations are there if they give you a certain number of objects? That's what permutation is about. So the count is what we need. And so let's understand the notation for the count of permutations. Number of ways of arranging R objects taken from n given objects. If they give you n objects, and if you're supposed to take R objects from it and arrange, then all the ways of arranging them will have to be counted, all the different ways. That count is written as PNR. The PNR represents the count of those. So P stands for permutation, N is the given number of objects given, R is the number of objects you need to choose and rearrange. And all those rearrangements have to be counted, and how many are there is the question. To understand the idea, to understand the situation, I'm going to do a simple example first of finding P32. P32 means 3 objects are given. In how many ways can you take 2 and rearrange? That's what it means. And we need to count all of them. Okay, we can use 3 objects means we can use 3 letters to represent those objects. The problem applies to any object that we are dealing with, but I'll use 3 letters, A, B, C. So if I have 3 letters to answer the question P32, P32 equal to what is the question? To answer that, I'm going to use A, B, C. And if these are the letters we are going to work with, give me a choice of 2 letters. I have to take 2 at a time. Give me one choice of 2 letters. Any one choice. Say it again.
A and B.
A and B. And now we have to rearrange it and count all those. So what is the rearrangement of those 2 letters? BA. The order matters to us. AB and BA are 2 different things, 2 different permutations. Now take another combination. How about AC? The rearrangement is CA. Any other combination?
BC.
BC. You have to take all possible combinations. The rearrangement is CB. And that's it. No other rearrangement, no other combination or rearrangement is possible. So these are the permutations. Permutations of 2 objects taken from 3. And how many are there? 6. The count is 6. That count is our answer, 6. So P32 is 6. Okay, so hope you understand the problem. This is our problem. The number of ways of P32 stands for the number of ways of arranging 2 objects taken from 3. You have to count all the rearrangements of the 2 objects to come up with the answer. Okay, so going to exercise 10. If I ask you the question, how many 2-letter code words can be made using 3 letters A, B, C? With repetition, if it is with repetition, that's a different thing. So I'm going to do that first. The question here is, let's answer the question in the exercise 10. Write all the 2-letter code words made from the 3 letters A, B, C with repetition. All right, so let me clear the board, or part of the board. Okay, so the letters given for this exercise are A, B, C, and we need to take 2 letters at a time. So A, B, C are the letters. All the 2-letter code words. So that'll be repetition is allowed. So A is 1, AB is another, BA, BB, BC, CB, CC. The repetition is allowed, so therefore A, BB, CC are allowed. And then
What about AC?
I'm sorry?
AC?
Did I miss AC? Yeah, I missed it. Yes, you're right. AC and CA. Okay, I hope I haven't missed anything else. Okay, so yeah, we can see now that's it. The count is, how many are there? 3, 6, 9. There are 9 of them. So so if you allow the repetition, there are 9, right? So that would be, we can count this without writing it out. I wrote it out just to show you, but we can apply the multiplication principle we learned. We are making 2-letter code word, so 2 boxes to fill, and these are the letters I can use. So in how many ways can I fill the first one? How many different ways?
9.
No,
3.
3 different ways. I can put A or B or C in the first box. So 3 ways, and repetition is allowed. So how many ways are there for the second?
3 again.
3 again. So that's how you get the 9. So if you get that 9 without writing it out, you don't have to write it out. Now we are able to write it out when there are 3 letters. If I give you 10 letters, you won't be able to write it out. So that's why we had to learn to count without writing them out. And the box method applies there. 3 times 3 is the answer. That's if repetition is allowed. Now, if repetition is not allowed, then it would be simply AB, BA, right? BC and CB, and AC and CA. Same as what we have here. In other words, what I'm trying to explain to you here is, if repetition is not allowed, the number of code words you can make is same as number of permutations you can make. The permutation actually counts the number of code words you can make without repetition. So if the problem tells you that repetition is allowed, then this multiplication, the box method is the only way to solve the problem. The answer will be 9. If the problem says repetition is not allowed, then you can still do it by the box method. If repetition is not allowed, then how many ways are there to fill the first one?
3.
3. And how many for the second one?
2.
2. So you have 6. And you have exactly 6 here, right? So you can still use the box method, but the point I'm making here is the number of ways of arranging, number of ways of making code words without repetition is same as number of permutations. That's exactly what permutations are. So whenever the question is dealing with arrangements without repetition, that can be found by finding the permutation. So that's the point. All right, so let's So you can see that in the box, I have highlighted that piece of information. PNR is the same as the number of R letter code words can be made using given N letters. So when they give you N letters and you have to use R letters out of the N letters, you have to choose R letters and make code words without repetition. That would be same as the permutation, count of permutation. All right, so let's do that with 4 letters. Then it will you will understand it better. So I'm going to do that with the 4 letters. So the letters given to us are A, B, C, D now, 4 letters. And it says find the number of permutations of 3 letters chosen from 4. So example 7 says A, B, C, D. 4 letters are given to you. You need to choose 3 at a time and rearrange them and count how many are there. Basically, we are trying to figure out what? P of what, comma what. Number of ways of choosing 3 letters from 4 letters and rearranging. That would be same as permutation of what number, comma what number.
4, 3.
4, 3. So 4 letters given, you need to choose 3 at a time and count all the rearrangements. And that would be same as making 3-letter code words out of these 4 letters without repetition. So let's go ahead and write them out. If I choose the combination ABC, then I have to rearrange and count all of these rearrangements. ACB, BAC, BCA, CAB, CBA. That's for the combination ABC. If I choose ACD, then I have more. I have all of them written on this worksheet right here. You can see all of them. So you can see that these are the permutations. And the count is 6 times 4, 24. There are 24 of them there. So that means P43 is 24. That's what we just figured out. We figured it out by writing it out. So do we have to write them out? Can we calculate them slightly differently? You can see that they're all, the permutations are all same as code words without repetition, right? You can look at this list. These are the permutations, and that they're also same as code words without repetition. So I can count to find P43, I can use box method. P43 means what? 3 letters, 3-letter code words made from 4 letters given to you. So how many boxes to fill?
7.
Boxes. We are making
3.
3. We are making code words consisting 3 letters. So that means 3 boxes to fill. And then you ask the question, in how many ways can I fill the first box?
4, and then 3, and then 2.
3 and 2. And if I multiply them, what am I getting? 24.
24.
Yeah, I don't have to write them out. I can use the multiplication principle to count it, right? There are 24 as we manually counted, and I calculated that using multiplication principle. So therefore, P43 is 24. Now, for these, we were able to do manual work. We were able to write it out. So let me ask you a question, exercise. If I ask you P6-3 and ask you to use box method to find the count. We know that all the permutations are same as code words without repetition. So therefore, we are going to count it by counting the code words that can be made. How many boxes to draw?
3.
3. And how many ways are there to fill the first one?
6.
six letters given. So how many for the second one?
5,
5,
then 4.
4, that's right. 120. See, it's so easy when you use the box method, and it's, I mean, it's hard, you can't write it out, it's too many. Even P630 is too many to write it out. 120 different things are there. So we can now count them without having to write them out. Okay, so
I have a question.
Sure.
So we're writing 3 boxes because they're asking for 3-letter code words, right?
Yes, no, they're asking, they're not really, the question is not code words. The question says, how many ways are there to arrange 3 letters you give from 6 letters given to you? If 6 letters are given to you, you need to take 3 at a time and rearrange and count. Exactly how, like we did for the 4. There are 4 letters given here, and the problem says, in how many ways can you take 3 at a time and rearrange? And here's one arrangement of 3 objects. So that's the question. How many ways are there to arrange 3 things taken from 4 things? That's what this says. To do that, we were able to recognize that all those arrangements are same as making code words without repetition, right? So therefore, we asked the question we transformed the question to say, this permutation is same as saying, in how many ways can I make 3-letter code words from given 6 letters? Okay, 6 letters given, we need to make 3-letter code words.
Okay, so if example 7 said write all the 4-letter code words, we would write 4 boxes.
Count all the 4-letter code words, you mean? Yes.
Okay.
So if the question is P64, then that means we need to make 4-letter code words out of the 6 letters given to us. So therefore, we need to make 4 boxes to count how many 4-letter code words are there. And then the count will be how many are there for the first one? 6.
6.
And
then 5. Then
5.
Then 3.
4 and 3. The product will be the number of ways to make the code words, and therefore the product will be the value of the permutation. The permutation is same as number of code words without repetition. Okay, so exercise 13, let's quickly finish that and we'll be done. Exercise 13 says find P95. Okay, how many boxes should I draw?
5.
5 boxes. Let me squeeze it in here. Okay, so I need to make 5 boxes, and then what are the numbers to go in the boxes?
9, 8, 7, 6, 5.
Right. And multiply them, that'll be your answer. So that'll be the value for P95. The value of P95 equal to the product of these. Okay. All right, so let's stop here. We are out of time. I will be explaining the permutation formula. I'll be showing you why this permutation formula is true in the next class. So for now, any problem that asks you to find P95, anything like that, you're going to have to use the method we just learned. Later, we'll have a formula to use. Okay, so we are done for the day, and enjoy the rest of the day and the weekend. I will see you Monday.
I have a question.
Sure.
Would there be any homework questions that we didn't go over today in class?
No, always I make sure your questions are within the material we have covered.
Okay, thank you.
You're welcome.